All right, we're going to go back over your quiz from this week. I know we went over part of it in class, but I wanted to do video on the entire quiz even so. So we're going to take the derivative of natural log of secant of x plus tangent of x, and the derivative of natural log, remember, is 1 over whatever you're taking the natural log of. So 1 over secant of x plus tangent of x, and then we're going to take the derivative of secant. Remember, the derivative of secant is a tangent times a secant. Derivative of tangent is secant squared of x. And when you put these together, we can factor a secant out of each of these terms. And so I'm going to multiply my fractions together, but I'm also going to take my secant out. So I have secant of x times tangent of x plus another secant of x all over secant of x plus tangent of x. And conveniently enough, we end up with two terms that cancel each other out. And your answer, therefore, will be A. For the second problem, we're going to use the quotient rule. So we're going to take that ho d high, derivative of high e to the x, derivative of that is e to the x, derivative of negative e to the x is going to be negative e to the x times a negative 1. And then we're going to take high times the derivative of the bottom, a lot of e to the x is here, plus e to the negative x. And derivative of e to the negative x is e to the negative x times a negative 1. All over e to the x plus e to the x, e to the negative x squared. So, a lot of stuff to simplify on the top. A lot of stuff to take care of. First thing I'm going to do is I'm going to rewrite these, and I'm just going to simplify the second term in each. I'm going to distribute that negative, or well, I'm going to multiply that last term by its negative. So we have e to the x plus e to the negative x times what happens to turn into the same thing, plus e to the negative x. And then on the second set of terms, we're going to have the same thing happen. Turns out that doesn't necessarily matter, but for simplification purposes, sometimes it comes in handy. In this case, we're going to FOIL our way through or distribute our way through anyway, so it won't necessarily matter that these are equal to each other. So, as we go through, we're going to distribute, and I'm going to use that box method. We're taking e to the x plus e to the negative x multiplied by itself And remember, e to the negative x is just 1 over e to the x. So here, as we multiply through, we get e to the 2x. You're going to add together the exponents, so e to the x times e to the negative x is the same thing as e to the x plus negative x, which cancels each other out, e to the 0, which is equal to 1. This is equal to 1. And here, e to the negative x times e to the negative x is e to the negative 2x. Now I know in class I did it a little bit differently, and I said e to the x, and I went ahead and wrote the e to the negative x as e to the 1 over e to the x. Either way, you can see that they're going to cancel each other out and you're going to get 1. So here we get e to the 2x plus 2 plus e to the negative 2x all minus, notice we've got the same thing happening here. Ultimately, I know this is kind of cheating, but I could simply erase my negative here, or sorry, my positive here, erase my positive here, put in negatives, which tells me that this will be negative, this will be negative, this will still be positive because a negative times a negative is a positive. So we'll get e to the 2x minus 2 this case, plus e to the negative 2x. And conveniently enough, we're going to have several terms that will cancel up on the top. So you'll have here your e to the 2x minus e to the 2x, 2 minus a negative 2, oops, didn't mean to put an x in there, e to the negative, or sorry, 2 minus a negative 2 will not cancel, but e to the negative 2x minus e to the negative 2x will cancel, and this will simplify down to 4 over e to the x plus e to the negative x quantity squared. So your answer here is going to be D. For problem number 3, we're going to once again use the natural log rule, and that says that we're going to take 1 over whatever's on the inside of the natural log times the derivative of that inside using a chain rule. So we're going to have 1/2 times x squared plus 1 all to the negative 1/2 power, and then the derivative of the inside of that will be 2x. Here we'll see that our 1/2 and our 2 will cancel each other out, and we'll be left with the 1 over our square root times x over our square root. And that simplifies down to get rid of our square root since they're in the same thing and we're multiplying them together. So x over x squared plus 1 right here. Now 4 was one that we didn't get a chance to go over in class. Nobody was brave enough to volunteer for this one. As we go through, remember we just recently learned the derivative of our arc sine or inverse sine of x is equal to, we're going to take derivative of each piece separately, so the derivative of the first piece, the inverse sine, is 1 over the square root of 1 minus x squared. The derivative of our next piece is going to be 1/2 times what's inside the square root to the negative 1/2 power. And then that times, we're going to take the derivative of the inside of that. We're using the chain rule here, times a negative 2x. Now we just have to simplify. And simplifying might be the worst part, or remembering what the derivative of inverse sine also might be the worst part, depending on where you're at. So what I see here is my 2's will cancel. I see that my negatives here will cancel, and that I will be left with with 1 over the square root plus x over the same square root. Rather convenient, don't you think, that this problem gave us something that would have a common denominator? They go together quite nicely. And there you go. Oops, forgot the negative. That's why I get a different answer. All right, so right there. For problem number 5, you need to remember once again our integrals that relate to the inverse trig functions. I see here something in the form of 1 over a squared plus u squared, where my a is going to be 3, my u is going to be x, and remember the integral of that is equal to 1 over a times the inverse tangent of u over a, and then plus c if it's an indefinite integral. So this is going to give us 1 over 3 times the inverse tangent of x over 3. And then we're going for the definite integral from negative 3 to 3, which I think is convenient enough. So we're going to get the inverse tangent of 1 minus the inverse tangent of negative 1. Think about where your what the domain is of the inverse tangent function. I personally, when I think of this, I go to my special triangles. I know that tangent is the opposite over the adjacent, and if that ratio is 1, it means these two must have been the same things. And when I know that the hypotenuse must be the square root of 2. I can find it using Pythagorean theorem, but this is just one I have memorized with my angle here. So this tells me that the angle that I need is a pi over 4, based on the domain and my special triangle. And then the angle here, based on what I know about the domain, would be a negative pi over 4. If you have trouble figuring that out, go ahead and use a calculator. You should get a 45-degree angle. And then I'll go through at some point, and I'll do more with the unit circle with you. So it should be easier for you to discover. Put these together, and we have pi over 4 plus pi over 4, which gives us pi over 2, or 2 pi over 4. And that simplifies down to pi over 6 right here. Next problem. All right, this one hopefully was pretty easy for you, and if not, we'll just practice some more. The integral of e to the x is itself, except for we're going to take 1 over, we need to remember that when we take the derivative of this, we should end up with this, and this gives us this extra negative in there. So we get a negative e to the negative x. We're going to take that and plug in our bounds. So we have negative e to the negative 1 minus negative e to the negative 0, but that just means 0. This will become plus a positive. Remember, anything to the 0 power is 1. So we have negative e to the negative 1 plus 1. For our answer, you can see that we don't have anything written exactly like that, but if we change the form, 1 minus an e to the negative 1 means 1 over e. We see that we have that answer right here. Now on to the next one. For number 7, anytime you see a natural log inside of the integral, you should be reminded that if you set u equal to that natural log, the derivative of a natural log is 1 over x. To see both of them in the problem together is going to be pretty common. I'd expect you to have one like this on the AP test personally. Probably not more than that, where it lists the two of these together, but I do expect you'll have one. So we know our u, we know our du. This is going to be a rare instance where our du is matched with something that's on the bottom of the fraction. When we take this and rewrite it in terms of u, we're going to have just a simple u du. And the integral of that was one of the first that we learned. And so we can take that and plug back in our natural log of x quantity squared. Now you cannot put this up here with the 2 because we're not just squaring the x, we're squaring the entire natural log. So we can't use those rules that we learned before because that would have only applied to the x. We would have to find what the natural log is first and then square it and then take half of that instead of bringing this 1/2 up. But it really doesn't matter because taking the natural log of 1 and e are both pretty simple answers. The natural log of e, so you put an extra bracket there, natural log of e is just going to be equal to 1. And the natural log of 1, or the logarithm of 1 for anything, is always going to be 0. So we have 1/2 times 1 squared, which is 1, minus 0 squared, which of course is just 0. And our answer here is going to be equal to 1/2. We've got one more to go and then we'll be done with the problems from the quiz from this week. All right, on this last one, we see that we have a couple e to the x's. Because we have an e to the x upstairs, and we know that derivative of e to the x is always e to the x, I would say use a u substitution on this one, where you set u equal to the entire thing in the denominator, so that du is e to the x dx. That means that here we have the integral of 1 over u du, as we do our substitution. The integral of 1 over u du is the natural log of u. So when we plug back in what u is equal to, we get natural log of e to the x plus 1. Now you can't simplify that right off because of this plus sign here. If you were multiplying or dividing, there'd be different ways you could simplify, but for now, natural log of e to the x plus 1 is the best that we can do. So we're going to plug in our bounds and we're going to have natural log of e to the 1, or I'm just going to say e, plus 1, minus the natural log of e to the 0 plus 1. Remember, e to the 0, anything to the 0 power is equal to 1. So really what we have here is the natural log of 2. And we have the rule with with all logarithms, that if we were to be subtracting 2 logarithms of the same base, we could change that into a division problem. I love this about logarithms. So we can put them together into one logarithm, and we have the natural log of e plus 1 all over 2. And there we go. So beef up on these. All of these examples are examples of things that you'll see on your test next week. Beef up on these rules. If you have any ones from the Barron's book that you would like for me to go over, remember I got all these from the Barron's book. Let me know, and we'll go over them in class on Tuesday. If you have any questions over the weekend, send me an email, and if not, we'll talk to you on Tuesday.